Okay. So why don't we give them, the participants, another minute or two to join? And so hopefully we'll get others right away. Yeah, it looks like people are joining, so we'll go with one more minute here and then we'll begin. Okay, just a few more seconds here. Bear with us, folks. We're going to start in a few seconds. We're just giving people another few seconds to join. I know sometimes it takes a little bit to find the session that you're looking for on the agenda. Okay, well, I don't want to cut into the time for our session anymore, so I'm going to go ahead and begin. And I would like to first say welcome, everyone, and thank you very much for joining us. This is a joint session of the Repository Platforms for Research Data Interest Group and the Domain Repositories Interest Group. And I'm Bob Downs. I'm one of the co-chairs. Kirsten Leonard is also a co-chair of the Domain Repositories Interest Group, and then Lily Zhang and Devin Ray Donaldson are co-chairs of the Repository Platforms for Research Data Interest Group, along with myself. And today's session is balancing efficiency and effectiveness in data review practices. And first, I'm going to be presenting an intro and then a short talk, followed by Anne Catherine Rolfe, Joan Damerow, Songyong Kim, and then Devin Ray Donaldson is going to be moderating our discussion. Anyway, without further ado, let's move along. Okay, for those who are new to the RDA, I just wanted to inform you about our 6 guiding principles at the heart of the RDA community, and they are openness. The community is community-driven. We work with consensus, and it's nonprofit and technology neutral. All are welcome, including commercial organizations. We try to achieve some harmonization as well as inclusivity. And if you want to join the RDA, there's the link. It's rd-alliance.org/register. Moving along. The co-chairs, as I mentioned, I'm a co-chair. I'm from CEASIN, the Center for Integrated Earth System Information at the Climate School at Columbia University. Kirsten Leonard is the co-chair also of the Domain Repositories Interest Group, and she's from the Lamont Doherty Earth Observatory in the Columbia Climate School. And we also have Lily Zhang, a co-chair from the Computer Network Information Center of the Chinese Academy of Sciences, and Devin Ray Donaldson is from the Luddy School of Informatics, Computing, and Engineering at the Indiana University in Bloomingfield. So for the Repository Platforms for Research Data Interest Group, it's Lily, Devin, and myself as the co-chairs, and we're part of a long line of previous co-chairs, as you can see, and our Secretariat Liaison is Bridget Walker, and our tab liaison is Rosella Aversa. And then for the Domain Repositories Interest Group, the chair is Kirsten Leonard, and her previous chair was Peter Dorn. And Bridget Walker is their secretary liaison, and Victoria Smith is their tab liaison. So just a minute, for a quick minute, I want to tell you about the 2 groups in case you're not familiar with them. The Repository Platforms Research Data Interest Group is trying to improve the usability and technical capabilities of repository platforms by collecting usage experiences, defining requirements, evaluating implementations, and identifying limitations of current solutions, offering recommendations, knowledge collections, or new working groups to investigate the identified issues. And the Domain Repositories Interest Group is sharing their interests in data curation, dissemination, preservation, and institutional sustainability. And they provide a forum for sharing practical experiences and developing joint projects. So as you can see, both of these interest groups have interests in common. And so we're glad to collaborate on this joint session. And we have collaborated on several joint sessions previously, and the last couple were on the same topic of data review. And the last one was at RDA 23rd plenary in Costa Rica. And there everybody said, more work needs to be done. You guys need to have another session on this. And so we're really glad to have the opportunity to have this session with you. It's a little bit of a different focus, but it's still on data review. And today we're looking at ways to balance efficiency and effectiveness. And to do that, first I will be speaking, giving this intro as well as a little bit of a talk by Kirsten and myself. And then we're going to have Anne-Catherine Rolfe talking about the Planetary Data System external peer review requirement, process, and benefits for the small bodies community. After that, Joan Demerol will talk about scalable data set reviews to promote fair environmental system science data in the ESS Dive repository. And then Song-Yong Kim will talk about curation workflow in an institutional data repository offering open and controlled access digital data at Becker. And then after that, Devin Ray Donaldson will be joining us to moderate the general discussion. Devin had some issues this morning, and I'm hoping he'll be able to join us.
I'm here.
Oh, great. This is great news, Devin. Good to hear your voice, although I can't see you because all I can see is my screen. So yeah, if there are questions in the chat and I'm not seeing them or people are giving me alerts, please feel free to interrupt me and let me know.
Bob, do we have a document where people can sign up so that we have a record of who attended the session?
Okay, yes, we do. That's in the first slide. Let me see if I can get that. Or Devin, are
Great.
you?
Thank you, Andrew.
Oh, Andrew put it in. Oh, great. Thanks. Yeah, all I can see on my screen is the slide I'm looking at and nothing else. It's kind of crowded already. And so I'm glad you were able to join us as well, Kirsten. Okay, and then moving along. So we wanted to share with you some initial questions for consideration. And also we would ask you to think about additional questions and perhaps jot them down so that in our discussion we can talk about some of these issues. But for some initial questions to think about while we're starting, think about how we can reduce the time required to complete effective data peer review. Also, how multiple data reviews can be conducted effectively without burdening the reviewers. Remember, these are volunteers, the reviewers. And then also, which aspects of the data review process can be automated. And then moving forward, we want to talk about pursuing opportunities for efficient and effective data review practices. And Kirsten and I are glad to be able to share our collective experiences here with you about this. As I mentioned, Kirsten is from the Lamont Doherty Earth Observatory at the Columbia Climate School. And I'm still working for a season at the Columbia Climate School, but I'm not sure how much longer I'll be there, given the situation. Moving forward, though, we represent the Astromaterials data system, and we're continually striving to improve the user experience. And we use open data from laboratory analysis of extraterrestrial samples. And we're doing this to increase knowledge of our solar system, looking at meteorites, data from moon rocks and space dust, and most recently from the asteroid Bennu samples. And we're trying to serve users across disciplines so that they can benefit from open data on the astromaterial samples. And by curating the data, that enables us to go beyond the team that produced the data, have a lot of different users representing various disciplines. And if we can get sufficient peer review, that will offer opportunities to improve data quality and usability. And Kirsten, please feel free to jump in at any time if you have additional ideas or comments you want to share, of course.
Thanks, Bob. I might do, because I just attended a workshop last week that gave me a lot of new insights into the issues.
Great. That's fantastic. Thank you very much, Kirsten. And so I did want to share with you this typology that we developed based on various discussions we were having with different groups about the data review process. And here you can see we have two axes, and along the top we have the internal data review, that is, and various people have different names for that, versus the external data view, which is on the right side. And then along the side at the top, we have automated data review versus manual data review at the bottom. And see, by dividing this into 4 quadrants, we can show where a repository fits along this. And ideally, a repository, their practices will evolve as they improve their capabilities and ways of providing their services. And so if they are initially perhaps only providing internal data review, and it's a manual process that could be, say, curatorial data review. Other repositories have different names for that, but that would be in the lower left quadrant there. And as they move to more automated capabilities, above that, they could get into metadata and data parsing. And then if they're able to then also initiate external data review, they can move their processes to the right. And so ideally, they would have data peer review, that is, the independent reviewers who are outside of the repository would represent expertise in their respective fields and be knowledgeable about the instruments that are used and the methodology, so that they can review the data through a full data peer review. And then ideally, if they could even automate aspects of that, we could move up further and have automated aspects of the data review process. And then we would have the third-party metadata and data review prior to or after submission of the data. So ideally, we would want a repository to move from the bottom left corner up to the top right corner. in their practices, but each repository has different resources and is moving at their own pace. And so each repository should try to do well whatever aspect they're trying to perform, and then also at the same time trying to evolve their practices. And then here we have a UML use case of the data review process here, which basically shows the different actors that are involved here in the different parts of the data review process. And so you can see here on the left, the data producer, they're involved in data submission, and it might not be the data producer themselves. It could be their agent, or assistant, etc. But they're also involved in the curatorial review because the data stewards will be working with them to try to improve the way that the data can be used by the broader community. The data producer also is going to be involved in the evaluation of the data prior to release so that they are sure that what they would like to present to the user community are there, and the advisory board may be involved in that. When I say advisory board, that could be including members of the management of the repository. That could include like a user working group representing the users. It could be members of the sponsoring foundation or agency that's involved in the data repository, and all these people might want to be involved in the release evaluation as well as the data producer. And then finally, the data producer is going to be involved in the community review process, and hopefully the users are going to be involved in that. Once the data are released, the users should be able to provide comments about issues associated with the use of the data, and ideally that information could be brought back to the data producers so that perhaps they could even revise the data and have a release of a subsequent version, for example. We also see the external reviewers. They're involved primarily in the data peer review process, and as I mentioned, the data users, they're involved in the community review. And as you see on the right side, the data stewards are, which might be a variety of different roles representing the repository. They're involved in not only the curatorial review, but the data peer review process, the release evaluation, the data publication, and the community review. And so, yeah, we see we have lots of roles for the different categories of actors that are involved in the data review process. And so we also have challenges for attaining efficiency and effective data peer review. And such challenges include implementing a system to facilitate the data peer review process. We want to have a transparent workflow that engages the different actors, including the producers, the curators, and the peer reviewers. We also have a challenge for recruiting and rewarding the volunteers who are going to serve as the data peer reviewers. We can't ask too much of volunteers because they're volunteers, of course. And so this is going to be a challenge. We need to make sure we have reviewers who represent the expertise that's needed for the different types of data that we get. And so, and we need to be able not only to recruit them and reward them, but we need to be able to coordinate the peer review process, that is assigning the correct data to each reviewer without, as I mentioned before, overburdening any particular reviewer. our volunteers. And, you know, we can't thank them enough. And likewise, I can't emphasize enough the importance of uh, repositories being able to reward the volunteer reviewers. And at the same time, we need to make it efficient for them to complete their high quality reviews. And then if we can automate aspects of it, I think that's going to help everybody, including the peer reviewers. And, you know, some approaches, there was a great session last night, yesterday, where time zone is, uh, about the artificial intelligence, for example. But if we can leverage ontologies, artificial intelligence, and machine learning, I think this will certainly help us to move forward along that process. So anyway, I want to thank you. And Kirsten, did you want to add anything more before we move on to?
Yeah, let me
Anne?
just add to this last point about automating. So as I mentioned, I attended a workshop last week in Germany that was focusing on sustainability of standards in chemistry specifically. And there were a number of presentations about the relevance of automated data validation. And the foundation of all of this is obviously very good standards. This is for Astromat the big challenge that geochemistry, cosmochemistry does not have community governed standards. So it's difficult to build the tools that do data validation against a standard. But for example, we had representatives at the workshop from the Protein Data Bank, from the International Union of Crystallography, where standards are very far evolved and where tools are used across the community to show that that data sets comply with those standards. And I think this is a really important perspective to take on data review, is that in the first place, we need the solid standards against which we can review and against which we can build the data validation tools and automate in the future. So maybe in a future session along the lines of what we're discussing today, we could look at communities that actually have those kind of very solid community governed standards. That was just all I wanted to add, because it kind of brings a perspective of the level of effort we're looking at right now versus when you try to scale it up across even commercial data that gets published and so on.
Yeah, those are excellent points, Kirsten. And yes, it would be great if we could continue moving forward, looking at these communities and the standards that they're adopting to improve the data review process. And again, thank you very much, Kirsten. And so with that, I'm going to stop sharing, and I'm going to ask Anne Catherine Rolfe to join us. And please welcome Anne. If you could share your screen, Anne, too. We were really eager to hear what you have to say.
All righty. There we go.
Yeah, looks great. Thank you very much, Anne. Please go ahead.
I've been getting notices that the internet at the hotel here is having occasional problems, so bear with me. I usually come back in about 3 seconds. I'm Anne Rao. I'm from the University of Maryland. I work for the Planetary Data System, and part of data acceptance for the Planetary Data System is what we call an external peer review. People not affiliated with the data set judging it. Well, judging it. Yeah, that's what we do. We judge the data sets. Okay, why are you not there we go. So a quick overview of what the PDS is. We are NASA's Planetary Data Archive. That means missions, ground-based research and analysis. If NASA money pays for your planetary data, then it ends up in the PDS anywhere in the solar system that you're looking, except for the sun and Earth. Everything else is under the purview of the Planetary Data System. We are specifically tasked to maintain the data in a usable state for future generations, and we have been since we were first formed about 30 years ago. Our data providers, unlike many other archives, our data providers are usually under contractual obligation to archive with the PDS, so they don't have a choice. And we're kind of cognizant of that. It's a distributed archive. I work at the small bodies node where we deal with all data related to comets, asteroids, interplanetary dust, really anything that isn't specifically covered by some other node falls under the purview of the small bodies node. So we have a large variety of targets of interest, everything from little grains of dust up to Pluto, Charon-sized things, interstellar objects, the occasional Tesla that flies through your field of view. We also have highly heterogeneous data because in the small bodies community, you'll take every bit of data that you can get. So we have radio science data as well as LiDAR data from flyby missions and orbiters. We have lots and lots of imaging. We have dust counters. We have a wide variety of types of data and analytical disciplines involved in our node. So we're serving many disparate communities with our data. Oops, I'm sorry, I just hit the wrong button. Sorry about that.
Looks good.
Yep. So our review model, our external peer review goes like this. The reviewers involved are the PDS generally, there's a central evaluation. The small bodies node in particular are external reviewers who are required to be not employed by the Planetary Data System small bodies node and not involved in creating the data product to begin with. And then we also include the data providers in the review process. It just makes everything go easier. So the PDS generally checks standards compliance. We have a canonical validator. An information model dictates what metadata is present in the labels and the format that it takes and handles the local standard vocabularies. So that's checked automatically. That compliance check is done with PDS canonical software, and SBN checks for things that are of particular interest for each data type to make sure that the metadata that's specific to that data type is there. Our external reviewers focus on completeness and usability. So they are reading the documentation, making sure that the data files that they expect to be there are there, calibration files are provided, plots for filter curves, that sort of thing. The reviewers present their report at a face-to-face meeting, generally. These are actually usually hybrid nowadays. We review many data sets at a time. Typically, they're related, so we'll review all the instrument data sets for a particular phase of a mission. Or we will have a ground-based review for comet data taken at various ground-based observatories. As a result of the discussions at the meeting, there will be a list of needed corrections that we refer to internally as liens, which is handed back to the data provider. And then the data provider edits the data according to the liens, sends us the final copy. We do an acceptance check to make sure we've checked all the boxes on the liens list, and we accept the data for archiving. And the timeline for this, for mission data, is typically 2 to 3 months from the time we get the first copy of the data for review to the time when we get the final copy and post it for the public. In practice, we have found that our reviewers do exercise the documentation and the data. We ask our reviewers to try to use the data to do something. So they do things like reproducing the calibration if they've got raw and calibrated data. They will attempt to reproduce a published result if they're looking at data for which there is a published result. They will try to compare the results from this data to an instrument that was operating at the same time, that sort of thing. So they seriously try to use the data, and they are very conscientious about it, and we love them for it. As a result of that, thankfully, most of the liens that we get, like 95% of the liens, are on documentation and metadata. The actual data bytes themselves are usually fine. It's a question of, do I understand them well enough to use them? And so we get a lot of liens from typos to, you didn't include a calibration description and you really need to do that. We can't have the data without it. And so those are the liens that are being resolved by the data providers. We also realize that missions and people who are providing data from research and analysis grants, they don't have infinite money. Up until recently, only missions were actually funded to do archiving. So RNA people got an obligation dumped on them to archive that they had not budgeted for. They are now being budgeted to do that in most of the programs. But we realize there are time limits, there are resource limits, there are end of funding periods. And so we try to be reasonable when we request things, and we will typically offer a mitigation. If reviewers requested that you provide this new column in the table and that would require rewriting pipeline, then we'll talk about, okay, well, if we provide it as a separate file, then if we go back and refresh the data, we might be able to merge it in at a later date, and at least we've got the information. That sort of thing. So yeah, there are drawbacks. It's time consuming. Obviously, it is labor intensive for the reviewers. The fact that our data are so heterogeneous means that when we do a full review, we try to get 2 reviewers for each type of data that we're reviewing. It still means we need half a dozen to a dozen reviewers, and we're doing a 1-day or 2-day review that passes through all these different types of data. It is very complex to get that many people to agree on a time frame to have reviewed data. We try to be as flexible as possible. We've tried reviewing in different ways. We're very concerned to make sure that the actual quality of the review that's done is the important thing. So if we can accommodate reviewers by having Zoom reviews entirely, by separating out instruments, by having little tiny data sets reviewed relatively quickly, we do that. We're conscious of that. But there are a lot of benefits. Since we're required to maintain usability of the data, it is comforting to know that it was usable at the time we accepted it for archiving. And our reviews do demonstrate that at least discipline specialists can use the data. When we have multiple disciplines represented in a review meeting, all the reviewers and everyone present there is involved in the discussion. So we do get some interdisciplinary feedback at those larger reviews, which can be very insightful when we start talking in jargon and the other disciplines start asking questions. Errors and omissions are corrected while the data creators are still where we can get to them. They're collected in one place, they're focused on data. So if we have liens, it's usually pretty easy to get an answer. We don't have to call people out of retirement or chase them down in a new job. We can demonstrate that the data are better than we got them. We have a list of things that we've done to improve the data set as a data set. It's also true that we get better submissions. So the first review of data from a mission is usually pretty rough, but they get better because the changes are made to the pipeline, and then we get better quality data as we go through the mission in terms of metadata support and documentation support. Our reviewers frequently go on to become data providers who then produce low lien count data sets, which is fantastic. It's like serving as a reviewer on a panel before writing a proposal. And the fact that we have so many different types of people in the room for a full review does help to broaden the discussion and get some aspect of interoperability. But that's the hardest thing for us to do, is to try to evaluate interdisciplinary interoperability in our reviews. So I will leave it there and take any questions.
Well, thank you very much, Anne Ralph. I see lots of comments and questions and even responses in the chat. But I was wondering if I might just first ask this question, and that is, in you describing your review, it sounds like you were reviewing many data sets with one set of reviewers.
Yes.
Within a 1 or 2 day time frame. So
yeah,
So like, how many would that be? How many reviewers might you have assembled? And how many data sets might you be reviewing with those assembled reviewers during that time?
Okay, this is typically, most of the data that we review is from missions. So a small mission will have 6 different instruments. At a typical review, we will review data from all 6 instruments. So that's 12 reviewers right there. And each instrument typically provides both raw and calibrated for the mission phase that we are reviewing. So we would expect at least 2 data sets, and sometimes there are 3 because there are additional products that are provided, or 4 because we're actually doing 2 phases at the same time. These data sets could be anywhere from 20 or 30 gigabytes to 20 or 30 terabytes, depending on the instrument that's being reviewed. Things that do imaging tend to produce a lot of data. Things that count dust particles tend to produce a little amount of data, but it takes the same amount of effort to review because it covers the same time period.
I see. So if I might follow up before we take Uwe's question. So if you have 12 reviewers during that time frame,
Mhm.
in addition to the 2 who are directly assigned for a particular data product, would the other reviewers also be commenting on those same 2?
They frequently do. Yeah. As the discussion goes, the primary reviewer will present first. The
Yes.
secondary reviewer will then present. And then if there are serious reviews from the automated reviews from the validation, we have an information model that controls that, so we can do some automated standards compliance validation. If there are serious problems, we'll discuss them because they require a change to the pipeline. Otherwise, those typically just get read into the record and we move on. And as the discussion of any significant reviews from the primary and secondary reviewers goes on, we will frequently find that the other people in the room are involved because of the nature of small body science. It's a very interdisciplinary science because there is so little data available about from close observations of bodies. And so there is a lot of interest in any new data that is presented at our reviews.
I see. Well, thank you very much. And Uwe Schindler, he has a question too. Uwe, are you able to unmute your mic?
Yeah, okay. I just have the question. So this is impressive. The question, I'm coming from the Pangea data repository. So, you know, we also do a lot of review, but we don't have too many external reviews yet. So I'm really interested. So the question is, so the external review starts when you have imported the data set into your own system. So the external reviewers can look into it, or is it before all that? So it's already structured, so you did all your quality checks and the data is also harmonized, or is this something where the external reviewers also need to look into? And if you're choosing the reviewers, do you have some fixed reviews that you're always using for the same type of data, or is it quite random, like in the data?
We do have a pool. We do have
Yeah,
a pool
okay.
of reviewers. If you don't do a good job, we don't ask you back.
Okay.
But we do have a pool of reviewers. Sometimes we have an issue where all the people that we would ask to review the data set are actually working on the mission. So we go looking for postdocs, we look for graduate students, we go out to the community and find people who haven't maybe haven't worked for us before, with one experienced reviewer to kind of lead the pack. And then, you know, we rotate them through. But yeah, you have to keep track of the people who do a good job. We have the advantage in that our data is very fresh. Nobody's seen it before. So a big incentive to be a reviewer for us is that you get to see the data. The timeline question, typically we get the data at the small bodies node in something that looks very like our archive storage format. In terms of directory organization, and it has to have the labels. The data providers must provide the labels. We do a standards compliance check to make sure that if someone is going to use PDS4 tools to look at the data, those tools will work, because we don't, the data are supposed to be software independent. And so if the PDS tools will work, that's good. That means we've met the level of independence that we want. If somebody else's tool doesn't work, I honestly don't care, but it matters to reviewers, so it'll come up in the review. We want that minimum standard. At that point, we want to give the reviewers at least 2 weeks and preferably a month to look at the data. They won't look at it until 3 days before the review, but we try to give them that much time, just in case. Most of our reviewers, because they're discipline specialists, they have tools that will do things like particles data and create the plots that they use to do their analysis. So the PDS format, the PDS tools will get it into their analysis environment so they can actually do the analysis. And they have a couple weeks to do it, or get their graduate student to do it, or whatever they do. And they generally give us a report in the form of a PowerPoint slide now. As we're moving into the cloud, we're going to have to develop a review environment that I'm hoping will do a better job of helping our reviewers search through the data and look for specific things. Right now, it's basically a directory structure, and they pull the data that they want and do what they need to do. Shall we
thank
go to
you.
the question in the chat and then the next one?
Let's hold the question in the
Okay.
chat until the discussion, because we're actually running late here.
Okay, great.
And so, Devin, please make a note of those questions, and then let's move on and invite Joan Demeraux next. Joan, please take it away. The floor is yours.
Thank you. Let me share my screen here. Let's see.
Looks good.
Okay. So yeah, my name is Joan Damerow, and I'm the data management services lead for the ESS Dive data repository, and I'll talk a little bit about the repository in a minute. And I'm a research scientist at Lawrence Berkeley National Lab in the Earth Environmental Sciences area. And today I'll be presenting on our dataset review process, which is pretty different to the one we just heard about. And really our overall goals are to promote fair environmental system science data, but we don't have a whole lot of resources for review, and we don't have peer review. So yeah, so the ESS Dive is the data repository for the US Department of Energy's Environmental System Science program. So it's for projects that are funded specifically by this program, so that all of the data is searchable and accessible in one place. So we're really working with the scientists to publish and manage and use high quality data in their work to the extent possible given existing resources. We store, again, like a really wide variety of interdisciplinary data that spans natural and human ecosystems. This includes things like watersheds and coastal systems and cities. The data are highly diverse, and they're generated by different observational, experimental, and modeling research that's sponsored by this program. So we do have a challenge in ensuring that this diverse data are of high quality, given that we have limited resources for data set review, and our overall goal is to provide really efficient reviews. So our approach here that I'll talk about in the presentation is to provide resources for projects to curate their own high quality data. In general, they're responsible for the curation of their data, but we try to provide resources to make that easier. And then we perform efficient data set reviews, and we try to aim for these reviews to take place in just 1 or 2 weeks where possible. And this process, we try to ensure that the data set metadata accurately and completely describes the contents and purpose of the overall data set. And then we have some automated validation tools for the data set metadata, as well as some of community reporting formats that I'll talk about. And we're trying to move more towards the data contributors providing files that are machine readable using our community reporting formats. So we want to use our metadata data standards and automated validation to help also with making our data set review process more robust and efficient while enabling advanced search and integration at the same time, given machine readable files. So we require a standard set of metadata to describe all data sets, and this is the high level metadata like the title, abstract, authors, locations, time period, and methods. And beyond that, we also support 12 community reporting formats, and these are data standards that were developed by our partner projects to standardize metadata and data files of data types that are commonly collected by the DOE's environmental system science projects. So this includes some general or high-level reporting formats that are widely applicable to many, if not most, data sets submitted to ESS Dive, like file-level metadata describing files, CSV reporting or CSV formatting to make sure that CSV files are machine readable, locations descriptions, sample description and identifiers, and for that we mostly use the system for Earth sample registration template and IGSN IDs. We also have data type specific reporting formats such as soil respiration, leaf gas exchange, hydrologic monitoring, water soil sediment chemistry, and drone data. Most of these are described in the Nature Scientific data paper cited at the bottom of the slide, and we also have documentation on all of these in GitHub that provide templates and instructions on how to use them. So all of the data sets undergo a standard dataset metadata review, and this is based on general FAIR principles. They're mostly focused on the findable and accessible principles, but we're trying to move more into interoperability and reusability. Addressing any of the dataset metadata revision requests are required for publication of a dataset. And then when a data set uses one of our ESS Dive reporting formats, we conduct a secondary review and provide some reporting format recommendations along with the data set metadata request. But these aren't currently required for the publication of data sets. They're just strongly recommended. And that's because we're still developing tools for these. They're fairly new and yeah, they're not required at this time. We have an automated metadata assessment report that users can run before they submit their data sets. And this generally checks for high-level things like the presence or length of data set metadata fields, like the title, abstract, methods, location, and date. We do want to look more into like using large language models to help automate more of the content review, because a lot of that is still done manually. And to also include more specific suggestions in the automated review. So we are looking into that. The ESS Dive curator at this time then reviews all of the metadata content in more detail manually to ensure that it makes sense and it adequately describes the data set. This is an example of the automated assessment report, and here's an example of an assessment report that prompts the user to use non-proprietary file formats and provide unique keywords and location information in a title longer than just 6 words. So we also have some automated validation, both automated validation and a manual review process for all data sets that use one or more of our reporting formats. We have a relatively new feature called the ESS Dive Fusion database that monitors all data sets that are submitted to ESS Dive and validates and parses data sets that are adopting our file level metadata and CSV reporting formats. And what these do are provide a description of each file and also all of the variables included in CSV files. And formatting of CSV files so that they are machine readable and parsed and can be parsed and indexed. So this automated validation will flag errors like missing file names or required values, incorrect units or data types in the files. the Fusion database then parses the dataset files that pass all the validation checks and pushes those to a data index that allows searching data and variables within files. A final review is then sent via email to the contributor that synthesizes all the results from our manual curator review and our automated assessment reports, as well as the Fusion database validation. And once all of the issues are addressed, the data set is assigned a DOI and made publicly accessible. The data sets that address file validation issues will be parsed into the Fusion database and searchable via the Deep Dive API, which I'll talk about now. So the result here with this automated validation of our reporting format is that we can enable more advanced search capabilities that leverage the standard reporting format, looking into files within the data set. So instead of just searching the data set metadata that describes the whole data package, which may include hundreds of files, you can now use our Deep Dive API to immediately find the specific file and the data that you need. For example, you can find specific files that contain data with the term CH4 or methane. This is actually a really big advance for us. It enables users to find specific data very quickly instead of combing through hundreds or even thousands of data files. So our plan to advance our review is to expand this Fusion database to include additional reporting formats. So this is likely going to start with some of the general ones that are more often used, like locations, descriptions, and samples. The Fusion database was released about a year and a half ago. So most data is not currently available within the Deep Dive at this time, but we are seeing more and more adoption. I think over 50% of new data sets are using file level metadata and CSV reporting formats now. So it's a good sign, and we may even start to require at least those two high level reporting formats so we can have most of our data available for search within the Deep Dive API. But this graph is showing the overall adoption so far of each of our reporting formats. And so you can see the most used are the file level metadata and CSV reporting formats with well over 200 data sets each, followed by locations with about 150. So a big goal for us is to continue to work on promoting adoption through additional support and improvements, and also these automated tools for data submission and validation, and generally working more on incentivizing use of the reporting formats through advanced search and integration capabilities. To do this, it was really essential that we had an opportunity to provide funding for partner projects to work on reporting formats and associated tools for ESS Dive. And these are all experts in the field in which they were developing these reporting formats. So again, they were the ones who developed the original reporting formats, and now we have a new round of funding for some of them to continue working on those and other relevant projects. This currently includes a data curator who is helping projects directly with data curation. And we have others who are working on reporting format revisions. Like, as most of us know, that developing these kinds of community standards is kind of a continuing process that requires, going back and revising where needed, and developing tools that make them easier to use, and promoting adoption and all of this. So it's a continual effort, and that is one concern that we have, is that whether or not we will continue to be able to support these partner projects and be able to improve our tools over time. It's as we have new capabilities, there's more to maintain, and it's always hard to find enough resources to do everything we really want to do. But working with this group has been really essential in this process. So with that, I'd like to invite any questions, and this is some contact information if you're interested in our review process or any other aspect of ESS Dive.
Yes, Song Young Kim has her hand up, and thank you very much, Joan.
And this is fascinating. You know, I'm a data curator for institutional data repository. I'm going to talk about it later, but we have received 20,000 files, 60,000 files. So, you know, imagine someone tried to find the data they want. So file level metadata sounds fascinating to me. I would love to apply that to our repository, but this is a commercial repository. So I don't know how we can, you know, adopt your technology. We have probably have to work with the Elsevier who, you know, build that platform, Mendeley data and digital commerce data. So is there any publicly available API they can maybe implement? That'd be also, I can take it to them and then say, push the idea of having a individual file level metadata. But even then, 20,000, 60,000 files, individual file level metadata is daunting.
Yeah. And this is for specifically, we're able to index CSV files currently. I mean, the file level metadata, you can describe all of your data files and, you know, if there's any terms within the description, you can locate that file within the deep dive and get at least the file you're interested in. But we have, you know, more capabilities for those using CSV files where we have a data dictionary file where you describe all of the variables included in each file as well. And that enables the
data dictionary file is good for interpreting the column headings and what is allowed to tell you and stuff like that. But we try to kind of teach the requester, use a keyword in your file name. You know, that's one way to do it without having extensive metadata for each file. Our data file formats vary widely because it's generally a repository. I mean, CSV is just one of them. So you can have DICOM image files and I can have other, you know, flow cytometry files. So the quickest way, because most repositories don't give you individual file level metadata field, it's just the entire data set, metadata schema, you know, based on data set, for example, metadata schema, because we issue DOI. So I'm just trying to think of what is the best way to have individual file level metadata for all data types, not just the CSV. So if you can brainstorm, you know.
And we have that, like the file level metadata is just a file describing all of the files in the data set. So that's the first level, and then the second level that we have is the for CSV file specifically.
We could have captured it in a README file, for example. So we have a master README that describes the entire data set, and then there's a data specific information field, which I will talk about. Then they will describe each file, and they could include. Sometimes it's a massive data set will have multiple folders. Then each folder will have a folder specific README. Then they can describe individual file with some description with the keywords. They can be searchable, for example. So that's the one way we can maybe implement this, you know, searchable individual file metadata.
Yeah. And I can share in a minute our file level metadata and CSV reporting format documentation if that's helpful.
That would be great. Yeah, I would like to take a look at it. Thank you.
Let's try to squeeze in a quick question from Uwe before we move on to Song Young.
No, it was also a comment about the file level metadata. So I can also suggest if you require too many metadata from the creators of the file, it's also very, very hard. So there's also tools available to extract the metadata from images and so on. And there's especially the Apache Tika project, which can read many files that you get. And one of the maintainers of the project is also Chris Madman from NASA. So he did a lot of, so there's support for NetCDF files and whatever. So actually you can automatically extract a lot of file level metadata and provide it for reviewers and so on. And it also helps your data center. So that would be one recommendation.
Yeah, if you have any resources on that, that would or documentation that might have some information on that, we'd be really interested.
I will post it in the chat or put it into the document. Yeah.
Mhm.
Again, thank you very much, Joan. That was Joan Demerol, and our next speaker is Sung-Young Kim. And please, the floor is yours, Sung-Young. Okay, I see it in presenter mode. Yeah, there, it looks great. Thank you very much, Sung-Young.
You're on mute.
You're on mute, Sung-Young.
Sorry about that. Okay, I'll repeat it again. Thanks for inviting me to this session. My name is Sung-Young Kim. I'm a senior support scientist working in data management sharing services group at Becker Medical Library at Washington University, St. Louis. I'm gonna next. Okay, so this is a brief overview of my talk. So I'm gonna give you some background about our group because it kind of ties to what I do. And then we'll switch to Digital Commons Data at Becker, our institutional data repository, which is a topic of this talk. And I will briefly go over access type because we are medical school. So a lot of researchers work with the human data, which it cannot be shared openly. So we are very unique in that because we offer both open and restricted data access. And I will go over our curation workflow and then future directions of what we can do better, what we are considering to improve. So this is our building, and then this is our logo for the Digital Commons Data at Becker. So this is our team. We are only two-member team. So we have 2 senior support scientists, myself and Xing Zian. Our primary objective is to assist WashU medicine researchers to in effectively managing their data and complying with the data sharing requirements set forth by funders and publishers. So it's a very narrow scope, but it does have a lot of tasks we have to conduct. So this is a list of the services we provide. So I do a lot of webinars on data management, sharing policies and practices to educate the researchers. And then we do one-on-one consultation because there's always a special need they need to understand. So give them a tailored guidance and support. And we provide assistance with creating data management sharing plans. This is a big one. So since the NIH implemented a new NIH DMS policy, this has a huge demand. Nobody knew what to do with. So personally, I reviewed more than 100 DMS plans, but which actually helped me do my data sharing part, which involves institutional data repository. And not all data types should come to us. So we do give a guidance on how to select a data repository. And then we also provide assistance with using DMP tool, which is an online platform to write a data management sharing plan. And lastly, we're going to talk about, help researchers curate their data to share in our institute's data repository to meet the funder and then publisher requirements. So we do provide a self guidance. This is our website. So if you go to beckerdms.usu.edu, this is what you see. And this is the 6 steps under resources, so they can just review those on their own page. But if you request a consultation, then we get the request and we can give them more self-guided, more customized guidance. So what is a Digital Commons Data at Becker? So this is a WashU medicine. We have actually 2 institutional data repository because we have 2 campuses. One is Word, but that only offers open access. So we are unique in that because we offer both open and restricted access. So it's a WashU Medicine Institute Data Repository administered and managed by Becker Medical Library. We use the same platform as Mendeley Data by Elixir. And this is one of the great repositories supported by the NIH, but with the additional benefits that come with the institutional version of Mendeley Data, Digital Commons Data. For example, it allows bigger file size, like 100 gigabyte, and then we can have some customization in terms of metadata field. And it is a generalist repository, so you access all data types. And when researchers cannot find a domain-specific repository, they can come to us. And we built the decision tree for selecting a repository. And it meets all the desirable characteristics of a data repository for federally funded research recommended by NIH. So we put together a table going over each element of a desirable characteristic. And it does provide searchable study level metadata, and it's fully indexed by search engines. We assign DOIs as the persistent unique identifiers. And most importantly, we provide control access via data transfer and use agreement for sensitive data, for example, human-derived data. And this is a big one, free of charge. So it's a big one because everybody has to share the data according to new policy, but we don't charge for curation or no deposit fee. So that's a big one for researchers. And a little more about the Digital Commons Data Becker. So it's a highly customized version of DC data. We realize a lot of researchers are not quite familiar about data curation. So we need to kind of hold their hands. Many repositories allow users to enter information, and not necessarily it's done right. So, and they can ask questions. So we actually close the access to individual users. So we control. It's a manual curation done by our curators, Becker DMS team. It does improve data set quality. It's more consistent. And we put together a FAQ document customized for our platform. So we make sure data follow fair data principles. It's findable, accessible, interoperable, and reusable. Believe me, we get all kinds of data set that does not meet the fair data principles. So we have to kind of guide them through. So we collect the rich metadata and then use his whenever possible, including ORCID IDs or funder IDs, DOI, etc. And then make sure to convert the files into open file formats for interoperability and collecting license information, all necessary documents to help interpret and reuse the data. It does have a version control. Interestingly, Digital Commons Data Becker use AI to compare the different versions. If you look at it, it highlights. So if you have two versions, if you click on compare version, it will pop up like that. And then removed will be highlighted in red. Added will be highlighted green. So this is what it shows. So it's kind of good way to use AI to search that. But AI cannot go into the individual file and see the change. So we actually added another metadata field to describe what's been changed, like the history metadata field, version, revision history, sorry. So we created a new metadata field. It does have a data, actually I'm going to talk about data set metrics. It shows how many people viewed, how many people downloaded, but download is only available open access data. Restricted access I won't have it, but we manually track. And then we had a lot of metadata fields because not all institutions have ROR, so we actually manually enter that information as well. So, and if you click on here, this is a general FAQ by Digital Commons Data, but it's not quite relevant to us. So we actually created a custom FAQ document. So this is what it looks like when data is shared is open access. Here's the data metrics, and all the files are visible. You can freely download with no restriction. If the data is shared via restricted access, data metrics still shows, but only shows views because they cannot access how many people actually download. It's a manual process, and this is what it shows. But we try to capture description as much in detail as possible so people know what's in it. And another way we recently implemented is survey, for example. A lot of times people want to see the survey instrument, but if you put the survey instrument along with the data set, people can access. So we actually kind of circumvent that by creating two data sets, one for open access with just survey instrument, and anyone can access, and that's all they need a lot of times. And the actual data, survey data, is shared via restrict access, but many times they don't need to see that. So there's another way to go about it, and having both open and restrict access allows you to do that. So it's a very useful way to do it. So now let's talk about data creation workflow. This is an overview. First, people request, and there's a request form they can submit, and they provide details. Once we get the request, then we initiate consultation meeting and then understand the data. And first, we determine the access type. Does it involve the human participant? It does not. And then after that, we collect the metadata, README, a data dictionary, all the supporting files, and convert the file to the open file format. It's all part of curation process. If it's a human data, make sure it's de-identified. So once the curation is complete, then we submit the data to Digital Commons Data at Becker and then publish UI. And I want to emphasize this one. A lot of times researchers will come to us when their manuscripts are being reviewed, and publisher is requesting them to share the data and provide DOI. So it's urgent. So what we do is we quickly generate direct DOI. All we need is a title of the data set and then one author, corresponding author's name, email, ORCID ID. Then we generate the direct DOI, but it's not findable yet and until we publish it. But that meets the publisher's requirement. So then, researchers can provide that while we create the data. So we try to match the publishing the data set by the time the manuscripts accepted it and are ready to be published. So this is the first step, step one, request. So they can submit a request form from two places. The first is our website, DMS website. The other one goes straight to the Digital Commons Data Becker. And this is what it looks like. So this is just general consultation request form, but we pre-selected. So we know this is for data repatriation, they can provide the details. And once we get the request, then we only have two people, but one of us will schedule a consultation meeting to determine the source. Does it involve a human or it's not? If it's non-human data, then it's straightforward. Then one of us will request the basic information to give them a draft DOI, and then we set up a box folder. This is important. We set up a box folder and then give them access, and then they can upload the data set and supporting document. But there are two documents we request. One is a metadata template, and the other one is a README template. I'll go over that a little bit, and we kind of work with them to make sure they everything is follows the fair data principles. But this is where we fight a lot with the researchers because they want to do it quickly, and they a lot of times they'll go to other repository so that they can do it their way, but doesn't guarantee the quality. So there's a manual data curation process that guarantees at least data quality. So there's a value in that. If it's a human data, we ask them, did it involve the informed consent? And then there's IRB approval. If the answer is yes, then we request a blank informed consent form and the IRB approval number. Then we consult with our Human Research Protection Office and IRB to determine which data can be shared and what data access type should be used. A lot of times they will say, if it's an aggregate summary data, you can share openly. But if it's individual participant data, even if it's a de-identified, we have to share it via restricted access. So the once that access type is confirmed what can be shared, then we go through the regular data creation process. But this time, the box folder becomes very important because the box folder for the restricted access data type will be shared with the requester later, once it's published. So we have access control and everything. So that's why we set up this box folder to stage the data, curate the data, and eventually share it for the restricted access with the requester. So this is a README file. This is, everybody is familiar with the Cornell README template. It has a lot of information. So there's a section. There's a general information, sharing access information, data and file overview. And like I mentioned, when there are 20,000, 60,000 files, they organize in folders. So this can become folder names. And then, of course, we collect the methodological information. One of them is the people involved with the sample collection, processing, and analysis and submission. We recommend people to use a credit contributor role taxonomy so it matches better and then more machine actionable, and data specific information. And the README, by the way, goes with the data set and it's published along with the data. But metadata collection template is for the curator to enter the information into the data repository. So this is just an Excel spreadsheet, and we give them a guidance. And one of them is we allow embargo, but the keywords is important. A lot of times people just pick random keywords, but we highly recommend to use match terms, because match terms has unique identifiers. So it's really good for findability and machine actionability. So whenever possible, they should go there. If it's a data set supporting the manuscript, you can just plug in the abstract. It will actually, populate all the match terms you can use. So that's a great way to do that. The last step is to publish. Once the creation is complete, the sign creator will upload a data set and supporting documents to Digital Commons Data Packer and enter all metadata. And our repository manager conducts a final QC check to ensure all entered information correct and is consistent. And if it passes, then we publish the data and the DOI becomes findable. So once we publish how people access the restricted data, this is a process. As I showed you earlier, you have to click the button, contact author button, then we get it in our inbox, and then we'll follow with the email. And then we have to kind of explain the process. And one of them is that they have to provide a statement of work, and then DTUA has to be signed by institution, not individual user. And that actually is really a huge barrier. So a lot of people will, just retrieve, they won't go through. So we have one data set is gaining a lot of traction, a lot of people request, but not even half of them go through because of it. So we are looking into how to make it a little more accessible. I'll talk about that later. So if they actually do go through and have an institutional signature, then it's DTU is fully executed and access is granted to a box folder containing, not the Digital Commons Data Packer, for a specified period, not forever. And then once they download, we close the loop. So it's a much controlled manner, and then protect the privacy of the restricted data.
1 minute, Song-Young.
Sure. So the next step, we are looking into many things. One of them is we have a lot of big data, so we are looking into options to share the huge data set using Globus. And then, like I said, there's a barrier for the restricted data set, so we are looking into click-through end-user data user agreement to lower the barrier for access. And more domain-specific metadata templates. We have a Midflow site template, but we're looking into the CEDA metadata template integration. And last, AI-assisted data creation. This is a big one. I'm looking into this fairly as a QC tool. I'm going to talk about it. This is a RDA project. It's called the data visitation for RDA. So I would like you to check it out and then test it, because this one is a quality control on data using OpenAI within the Fairlaser platform. So it connects to the ontology and standards we talked about in the chat section. So it's a very, very good way to improve your metadata and all. So you can also contribute to provide the feedback. So I would like you to check out the Fairlaser FAQ data selection guide, watch the short video, scan this QR code to Fairlaser. So thank you, and I will end it here.
Well, thank you very much, Song-Young. That was really great. We don't have a lot of time for questions before we get into the general discussion. I don't want to encroach on Devin's time here. Why don't we just quickly ask you Ho-Jung Yu's question. Do you de-identify sensitive data manually?
So I forgot to mention, so we don't provide the identification service. So the request has to do it on their own. We do check to make sure it's de-identified, but it's a manual process for now. And if you're going to use AI, we have to make sure it's HIPAA compliant. So that's another, hurdle. So make sure AI tool we use is HIPAA compliant when you feed this highly sensitive human-derived data. But during the curation process, we do check to make sure they actually remove all HIPAA identifiers and everything.
I see. Thank you very much, Song Young. So I see more hands raised, but I'd like to give the floor to Devin, Devin Ray Donaldson, who's the moderator, because we are running out of time. And let Devin, if you want to either work through the questions from the chat or call for general questions or address questions just for one speaker, that's your prerogative. I'll take it
Yeah.
away, Devin.
Okay, so I know that there's been some questions that have been asked, but also answered by others in the chat. So for, is it Kosuke Tanabe? That was saying, I'm interested in how the researchers in other research fields have established criteria for evaluating data sets. Would you like to elaborate on that, or do you feel like that was answered by who replied to you?
Thank you. Thank you. I think general question, yeah. So yeah, my question to all of the speakers.
Okay, so you want to just ask it or recast it, and then others can respond?
So yeah, so okay, so could you sorry, I forgot the first speaker.
Yes. So, all right, I can just read what you said and then others can chime in. I'm interested in how the researcher in other fields have established criteria for evaluating data sets. I talked with other researchers, material scientists, about that several years ago, but all of them said it's impossible because data is extremely diverse. So is there anyone that would like to respond in addition to who already did?
Yeah, I'll just quickly say that we find with all the different instruments available for conducting analysis of astromaterial samples that it really presents a challenge for us in that regard because of not only the different instruments but the different methods. So we're trying to work on that challenge, but I think that's a very important point that's been raised, and we need to improve our capabilities in that regard as well. Others want to speak? Either Joan, Ann, or Song Young? I see Ann hand raised.
And
I was reading the chat, the question as I missed it. But one thing I wanna talk about is it's hard to get fast, cheap, and high quality at the same time. So I do believe manual data creation process really improves the data quality, but it's not possible. I actually answered one of the questions. So as a data curator, our job is not reviewing the actual data. We leave that to peer reviewers who are reviewing the manuscript data set. So our repository has a way to give them a private link for the reviewers to review the data set, because we're not the experts. I have a science background. I've done a lot of different researches. I have pretty good understanding. I can make sure they follow the community accepted standard ontology and follow FAIR data principles, but individual data level, I think it needs a deeper understanding, like a peer review, and we leave that to the peer reviewer. So we actually try to do, fast because they need it, publish it fast to meet the funder and publisher requirement, and then high quality, make sure data is reusable. That's the important part, and analyzable. And FAIRlist will actually help your data to be analyzable. So I like that part about it. But speed is, I think it's hard to involve so many external reviewers. I didn't mention data curation network primers that allows you to automate some of the data curation process, but it won't go deep down into the individual data content-wise. So that's the limitation in a way. So I just wanted to put that in.
Okay. Like
Thank
Anne
you
there?
so much.
Yeah, with respect to diversity, because we've got a lot of that in planetary science, we developed an information model where we could put the metadata items that are most commonly used for general searches. Our data is so diverse that there is no single attribute that you can use to search across everything in our data holdings. So it's difficult, but there are some things that hit at the 90% level or the 80% level. And so they comprise our core metadata definitions. And then we realized that metadata was going to continue to evolve. People searching for data are going to want to search on things that we didn't think of at the time we ingested the data. And new instruments will require new descriptions, new studies will be developed. And so we designed an information model that could be extended. And that's what we do. We've been doing that pretty much from day one. We extend it for specific types of instruments, for specific types of missions, for specific targets and ways of observing, so that the metadata has a sort of layered approach to providing the information that is needed. Simple data, simple metadata, complex data, complex metadata, and the user can search at the level that they're interested in to find what they need.
Great.
Yeah, thank you so much.
So Lars Mollier had a question. How do you ensure comparable quality standards in terms of the data reviews among the reviewers? And how do you teach them complex review steps? Does anyone want to respond to that?
Dev and I actually responded in the chat.
Oh, okay. Okay. So is there anyone else that had any points to elaborate with that? And thank you, Anne. Okay. Title 1 and 6 words.
There's a one question from Daniel I'd like to address live.
Okay, thank you.
It's a very good question. So I just shared a one link about 12 best practice of data sharing. So
And
requires
what is that? Another problem I find is a poorly descriptive title, or which one?
it's toward the end, I think. The Daniel
How do you balance the aspect of good scientific and
yes,
research
that one.
practices with the requirements of the journals? Okay.
So the publishers don't really require much. All they want is DOI of the shared data set. So I have seen actually DOI doesn't even work. So it's not good. But there's a really good article about 12 best practice of data sharing. And then that requires participation from researchers who generate data, but publishers and then data stewards like us. So everybody has to play a role. But since I do provide consultation, webinar and stuff, I have an opportunity to educate them. What I emphasize is if you manage data well, data sharing becomes so much easier. So do it right from the beginning. So writing a data management sharing plan really helps because you kind of go through the entire life cycle of your project and then think ahead and plan ahead. So, starting from file naming convention, structure of your folder, metadata template, README template in each project folder. If you do all that when it's time for you to share data, everything is there. You don't have to revamp everything. So I try to pitch that every chance I get. So I give them a consultation and provide a webinar about good data management practice. And then the sharing just naturally follows it in a way because you have all the metadata ready to go. You don't have to scramble. People turn over. By the time you publish data, the person might not be there. So just capture all the information as it's happening. You also have to make sure there's no error. You have to validate the data as you collect them. So that's the thing. But like I said, publishers don't care about that part because they care about make sure data is available for public supporting the manuscript. So it's a very different mindset. So, but we are working together. I think they can do better about it. And like protocols, for example, a lot of times there's a method description. It looks like a detail, but it's not really as helpful. But if you use a protocols.io, for example, it's a repository for protocols. It has a recipe-like steps. And then you can actually run the protocol, has like a timer, and then it's really AI-based. I mean, it's the machine actionable. And then you can run the record and then save it in electronic lab notebook. So everything can be done more efficient way, and then tie through the PIS, like the DOI for protocols, rather than writing this the same thing over and over. And then it have a version control. So when people click on DOI of a protocol, it is saying, hey, there's a new version available. Would you like to see it? So not only has the version that was used, but there's improved version you can follow. So there are many ways we can improve the practice in a way. I hope I answered your question. If not, please feel free to add more.
Anyone want to add anything?
I think Uwe has a question too.
Right, he does. So, how do you ensure if a draft DOI was given to a submitter that the submitter provides corrections after review at a later stage? Does anyone want to respond to that?
So in our case, it's we do it manually, so we have a control. So draft DOI doesn't change when we publish it, but once it's published, then it has a version control. So like I showed you, so each version, if you click on compare versions, they show, and submitter cannot change anything because it has to go through us. We're the gatekeeper. So they cannot change anything. And then since we use a box to, collect the data, if they change anything, we can see the change history. There will be a version. So there's another way to keep track of that. Did I answer your question?
Sorry, the question was a little bit the other way around. So often what we noticed, so people want to get a DOI as quick as possible. That's often the case. And then they get the DOI, but they never ever come back to you with corrections because they have a DOI already, and so they are lost. And so the
I
idea
see.
is how, yeah, so
They might not go through the whole
yeah.
process and publish
Yeah.
it. That's what you're worried
Yeah.
about.
Yeah, exactly.
It's a good question. It could happen. They might have given the draft DOI to publisher, but they never actually published.
Yeah.
It's on them. We don't have much
Okay.
control over that. But when the paper is published, we normally follow up. Hey, do you want to do that? And typically, if the paper gets accepted, they are more urgent to get the data published. Only if they get rejected, then they don't follow up. Then they have to submit it to another, publisher until they get accepted. Then that's when they actually take an action and finish the creation and publish it. So good question. Thank you.
So yeah, Kasuke say some researchers are afraid that the research process will take a long time. They ask me if a competitor publishes data and paper before I do while I'm waiting for your review, how will you take responsibility? It's hard to answer that question. Bob, are we out of time now?
If people want to stay on for a few more minutes, I think we can continue. That's certainly a great question. We often see that concern where, people don't want to be scooped. And that's a particular challenge. Generally speaking, what we as a repository would want to do is to try to get that data out as soon as possible, so that the publisher will have it in time. But that is a challenge because of the review process takes time there as well. So yeah, I'd like to hear what others have to say about how they address that as well. Either Anne or Song Young.
I typically recommend research, if they are worried about getting scooped, I recommend them to use a preprint. So make that, publish, preprint, because it doesn't go through the peer review and everything. So you can claim it's been shared, but the data, specifically data supporting the preprint has to be shared in a repository, but it is there. So at least you can kind of earn the time, before you go through the peer review process and then get your paper published. So use a preprint, as much as possible. That's one way to ensure, you get your stuff out there.
Anybody else want to add anything?
Well, I do see a comment in the chat from Daniel Manrique saying that I think the fears of being scooped also need to be re-educated. And so, yeah, I would argue that we need education on both parts. That is, not only for the data producers who ideally should be trying to submit their data earlier if possible, so that there is time for that data review so they don't get scooped. But also, we need education for the community. That is, the community should be aware of the norms for using data, and that if the data producers are kind enough to share their data, it would not be right to go and scoop them on their work. I know a lot of people feel that pressures of the career, etc., force them to do things that they wouldn't normally do. But I think we need to, at the same time, remember that if somebody is sharing their data, and we want to encourage that kind of behavior, scooping them is not the way to pay them back.
Right.
So I don't see any other questions there now, and I know we've kept people over time and people are leaving, and we apologize for going over time, but there is so much to cover here. And in fact, it was suggested earlier that we talk further about these issues in terms of the communities and the standards being employed. And hopefully we'll be able to organize a session for RDA P24 in that regard. I'm not sure
25.
whether I'll be able to attend or not. I'm having, where I work, there are some challenges. You've probably seen them in the news. And so I'm not sure where I'll be or what my status will be. But hopefully as a team, we can get together and try to plan something. But before we leave, I would like to thank Kirsten, who already had to leave, and Lily, and who wasn't able to join us, and certainly Devin for helping to organize this and moderating. And then also I want to thank Ann Catherine Rao, Joan Demerau, Song Young Kim. These are great presentations that you
Yeah.
gave. And also I want to thank everybody for sharing their insights and their comments and thoughtful questions. This has really been great, and we look forward to future discussions.